We've been talking about atoms, but atoms can form ions. Ions are formed when an atom either gains or loses an electron or more electrons. We have names for positive ions and negative ions. Positive ions are cations, not cations. It looks like short for vacation, but it's not. It's cat ion. And negative ions are called anions. And so here's another one of those. You've got a pair of things, and you have to keep them straight. One's positive, one's negative, which is which? Well, I like cats. I have positive feelings for cats, and cations are positive. I know that's not going to work if you hate cats, so you have to figure out something. The best thing I can come up with there is anion has an extra N in it, and anions are negative. So those sorts of little tricks seem a little goofy, and yet they work. Okay, they work. And you can make up stuff like that for other things in your life as well. So atoms gain electrons, they become negative, anions, and they lose electrons, they become positive, or cations. And then when we write their symbols, we take the element symbol and we indicate the charge of the ion. And unlike in math, we usually write the magnitude first, followed by the sign. So let's look at an example of that. So here's an example. Lithium, the atom. So the symbol for lithium is Li, and as an atom it has no charge, it's neutral. Here's the reaction arrow, and it reacts to form lithium ion. Lithium ion has lost an electron, so the electron comes off. If it's lost an electron, which has a negative charge, then it now has a positive charge. And so we show lithium with a plus symbol. Okay, in math we don't do that. In math we would just write Li. If we have more, this isn't the best example slide here. If we have more charges, like let's say calcium ion has a 2 plus charge. So we write Ca2 plus. Phosphorus forms a 3 minus charged ion. Well, in math we would do it the other way. P minus 3, something raised to the minus third power. I don't know this for a fact, but I think chemists do it this way just to make sure that it doesn't get confused with a variable raised to a power. So we write the sign first, and then the number first, and then the sign. And if it's a 1, we just write the sign. So like iodine forms a minus 1 ion, and so that's pretty sloppy. I with a minus. Not a minus 1, not a 1 minus, just the minus sign. You'll find as we go through the semester that there are a lot of times where chemists do not write the number 1. I say we're efficient, but maybe we're just lazy. It's like if you don't have to write the 1, we just leave it off. Okay, it's kind of a pattern. So in looking at this, the charge on the ion is going to depend on how many electrons were lost or gained. So the lithium atom, the lithium atom has how many protons? Look on the periodic table. So lithium is element number 3, so it has 3 protons. The atom also has 3 electrons. If it loses an electron, then now it has 2 electrons. And so we have 2 negative charges and 3 positive charges, and that adds up to be a plus 1 charge, and that's why the lithium ion has a plus 1 charge. When an atom gains an electron, it's gaining negative charge, and so it gets a negative charge on the ion. So fluorine, the element, has 9 protons. The atom also has 9 electrons. When it gains an electron, now it has 10 electrons. We've got 9 positive charges, 10 negative charges. Those add up to an overall charge of minus 1. So the symbol for, no, I'm lost. Here we go. The symbol for the fluorine ion is F minus. It has a -1 charge. So here's an example. Let's determine the charge of each of these ions. A nickel ion with 26 electrons. Well, what's the symbol for nickel? Ni, right? So Ni, and it says it has 26 electrons, so that's -26 charge. How many protons does a nickel atom have? 28. So 28 minus 26 is 2 plus. So it's a +2 or a 2 plus ion. The number of protons is what identifies it as that element. It's like your soul, your personality. You can change your clothes, you can change your hair, you can do all sorts of crazy things to the outside of you, but you're still you, aren't you? You can't change who you are inside. An atom can gain electrons, it can lose electrons, the number of protons stays the same. It's always part of that element. So the nickel losing 2 electrons to become a +2 ion, it is still nickel. Okay, how about bromine with 36 electrons? The symbol for bromine is what? Br, and it's got 35 protons and 36 electrons, we're told. So that adds up to what? -1. We don't write the 1, we just write the minus. Phosphorus, what's the symbol for phosphorus? P. How many protons does phosphorus have? 15. And this says it has 18 electrons. 15 minus 18 gives us an overall -3 charge, so we write 3 minus. Okay? Now, the periodic table, you may wonder, well, why was it nickel 2 plus, or why was it bromine with a -1 charge? Does it make -2, -3 charges as well? Well, some of them can make multiple charges, a lot of them only make a single charged ion. And the periodic table can help us predict a lot of those things. So the number associated with the letter A above each main group element, on this periodic table we have in the classroom, it's kind of small to see from way over there, but here this column with boron in it says 13/3A. This one uses the Roman numerals. Some periodic tables only have the numbers without the A, and like we pointed out earlier, column 13 is column 3A. There is a relationship there. But the number associated with us tells us the number of valence electrons in that atom, and those main group elements tend to form ions in such a way that they get 8 valence electrons. So this is one of those things that we just have to kind of talk about. Do some examples. So here's a periodic table. And let's look over here at bromine. We looked at bromine earlier. So here's bromine over here. Bromine forms a -1 ion. It's in group 7A, which tells us it has 7 valence electrons. It wants to have 8 valence electrons. So is it going to gain or lose? It's going to gain 1 to have 8 valence electrons. Something like oxygen is in group 6A. Oxygen has 6 valence electrons. If it gains 2 electrons, then it gets 8. So that's why oxygen is 2 minus. A little harder to understand because we haven't talked about electron configurations and things. These guys over here, like lithium, lithium has +1 charge. Well, why is that? from what we were just talking about, we'd expect him to be minus 6, right? Because he's got one valence electron. That's lovely. One valence electron. And so he would need to gain 6 to get 8, right? Well, valence electrons are the outer shell, and when you peel off that outer layer, there's another layer underneath, kind of like an onion. And so if you peel off the broken layer on the outside, you get to a complete layer underneath. And so for these guys over here, they will lose an electron that's their only electron on the outside to get down underneath. Okay, so that's the approach the book is taking to showing you that. We can also look at this a different way. Group 1 makes, Group 1 forms +1 ions. Group 2 forms 2+ ions. Group 3 forms 3+ ions. Think you remember that? And look at the pattern here in the periodic table. All of the group 1, they're all making +1. The group 2A's, all +2. The group 3A ones that are shown there are all +3, right? So those guys are fine. It's the negative ones. And so this is what students seem to like. Let's pretend that we're playing a board game, and the start line is over here, and you're starting your marker here, and I want to find the charge on oxygen, so I'm going to count how many spaces I have to move backwards. I have to go back 1, 2 spaces, and I get to oxygen. I went -2. How about to chlorine? We start here on the far right, we go back 1, -1. All of these guys are -1. The next one over is all -2, and there's some over here that do minuses also, and they're all -3. Another way it's explained sometimes is take the group number and subtract 8. So group 6, you subtract 8, you get -2. So there I've given you 3 different ways to think about that. What am I doing here? So let's do an example. Based on their position in the periodic table, what ions do potassium and selenium tend to form? Well, where is potassium in the periodic table? It's in group 1. What kind of ion do group 1 ions form? +1. So potassium is K, it's going to make a +1. How about selenium? Selenium's over here in group 6A. -2. Selenium is going to form a -2 ion. If you're going to play my stupid board game, you start over here with krypton, and you take 2 steps backwards. -2.